Hello and welcome to another episode of Fall Through. Yes, fellow listener, or rather listener, your ears do not deceive you. It is I, Johnny Boursiquot, formerly host of Go Time, although Go Time is no longer a thing, but thankfully, folks like Kris and Ian and others have picked up where Go Time left off, if you will, they came through with Fall Through. Ooh, that pun was not intended. In any case, today I will be your guest host. Coming back to talk about what's new and Go is our friend Carlana Johnson. Carlana, how are you?
Hi, I'm excited to be back. If the listeners thought they could get rid of me just because Go Time was over, they were wrong. It's much harder than that to get rid of me.
Yes, indeed. We do like having you come through whenever there's a new release of Go, because we like to know what's new with the language, whether it be in the standard library, the tool chain, new improvements. We're here to talk about them. And Go 1.24, as of this recording, is not yet released, but hopefully that will be the case very soon, as we're sort of familiar with the release cadence of new Go versions. So hopefully by the time you're listening to this, we'll have released Go 1.24 or be close to it. So before we start, for those who don't know who Carlana is, Carlana, you want to do a quick intro?
Oh, I guess it's a new show, so I should reintroduce myself.
That's true.
So I'm the Director of Technology for Spotlight PA. We're a nonprofit newsroom that covers Pennsylvania statewide issues, and we do investigative journalism. So yeah, that's the main thing. I end up doing a lot of Go for my work. I did a blog post on Carlana.net last year about my 5-year anniversary of working for Spotlight PA. And I mentioned how the site is run, which is a combination of Hugo on the front end and a lot of Go stuff on the CMS side. And then JavaScript-wise, we're actually using a kind of small framework called Alpine.js, which I'm a fan of, but is not as popular as some of the other ones like React and so forth. Definitely check out Carlana.net if you're interested in seeing my face all pixelated and reading my writing, including I usually write something about the new release of Go. For this one, I don't have a huge post planned, but I'm definitely going to write about what I worked on for Go 1.24.
Nice. Yeah, I can catch a hint of it. And yes, definitely looking forward to talking about that. So let's talk. Obviously, we're not going to talk about every single thing in the release. There are lots of behind the scenes stuff, lots of sort of minor improvements that we may refer to here and there. But let's talk about sort of the things that are most likely to impact sort of our day to day, right, as Go developers. I think there's some new packages that are introduced, right?
Yeah, there are 2 new packages. So I like to say, like, what's the theme of the release? So for Go 1.23, you could say it was an iterative release because they added iterators. Right. And for Go 1.24, it's a kind of weak release because they have a new package called Weak. And that was a very weak pun, so on the theme.
Right.
Yeah, so the package Weak is a new package which follows after, actually, they also added a package recently called Package Unique. And so all of this is things that interact with Go's garbage collector. So a garbage collector, the basic idea is that when you have a variable or an object, you as a programmer don't necessarily need to know when was it created or destroyed or how many copies of it are there out there. The runtime will handle all of that stuff for you automatically. So there are other languages that don't have a garbage collector, like C, where you're just supposed to do it manually, and you're supposed to know by whatever mechanism that, it's safe for me to delete this because nobody else is using it anymore, or you have to keep track of it. Maybe you'll keep a little variable that counts how many people are using it, and then when it hits 0, you'll delete it on your own. And then Rust has it built into the language so that just in terms of the type system, it knows how many copies of each variable are out there and can automatically create and delete based on those type annotations. But Go is a garbage collected language, so it's all being handled by the runtime for you. But because of that, there are times where you run into little issues where it's retaining some memory, and you wish you could tell the operating system or the runtime system, this memory, keep it around if you need it, but like if nobody else is using it, just go ahead and feel free to delete it. And that's what package weak does. It only has, I think, one method, two methods. I'm looking at the release notes to see. But yeah, it has a function called make, and make returns a pointer, and pointer has a method called value. That's the whole package. We've gone through everything in there. And the way that it works is if you do weak dot make and you pass in a pointer, it will make a weak copy of that pointer. And then from then on, if you have the weak copy of it and you call value, it will return the original pointer unless it has been garbage collected. So what this lets you do is it lets you set up a caching structure where you can say, I'm going to put this into my cache, and then later, if I need to pull it out again, I'll look and I'll see if value still has something in it. And if it does, then good, I can use it. And if it comes out as nil, that means that, it was garbage collected while I was waiting, and so I need to recreate this value. And so it can be handy as a way of just sort of caching things, but not having memory just build up and up forever. Because if you tried to do the cache by just putting it into a map or something like that, then what would happen is it would never be thrown away because there would always be at least one reference to it. So this is a way of making a reference and saying, even though there is still a way of reaching this variable, don't count this towards garbage collection. Just ignore it.
Okay, so it sounds like that's something that you'd have a very specific use for, right? So most of the time, obviously, on account of the weak package, and its semantics haven't, not having been in the language since its inception, right? So that is something that perhaps some have asked for as a way of trying to manage memory better. Like it sounds like that's something that you'd have a specific use case for. If you know you need it, then you know you need it, kind of thing.
Yeah, this is something you're not going to just like reach for unless you've optimized your program, you've done some profiling, and you realize that there's a bunch of memory lying around that technically you're still using, but practically you would like the garbage collector to let it go. It's definitely a more of an optimization thing, not something that you're just going to reach for by default. There are similar changes that have been made along these same lines. Like I mentioned, the unique package was added before, and that makes it so if you pass in a variable, you'll get back the same thing. Or I guess how to describe the unique package. But the unique package, if you have like a string, and you have two copies of the string, you can make sure that it's referring to the same memory. So if you have like, I'm reading in some user input and I read in the word the, and then I read in some more user input and I get the again, I want to consolidate those two and make sure there's just one the object in memory and not two. And so unique lets you do that. So the combination of weak plus unique, it lets you do a lot more caching, optimization, memory sort of things than you could do just on your own without support from the runtime. The unique package was actually originally introduced as an optimization that was just hidden inside of the net IP type. So Go has always had an IP type, but Tailscale needed a faster IP type, so they created a package called NetIP, which was eventually merged back into Go proper. And as part of that, they needed a unique package. And so that was originally just an internal package to NetIP, and then it was promoted to being a full package that anyone can use. So this is along the same lines of research of let's get something that people have been able to hack into being. If you were a runtime expert and you knew exactly how the runtime worked, you could make a weak pointer before, but it was very dependent on the specifics of how things were set up. And if something about the memory management system had changed between, Go 1.x and Go 1.x plus 1, it could have just all broken. And so now that it's built into the language, you can rely on it, that it's not going to be, oh, go upgrade it, and something about garbage collection changed, and now my whole thing is broken.
Right. So this definitely sounds like if you've gotten to the point where you pretty much know what your performance characteristics are going to be. You've done the profiling, you've done the work, and you're really trying to squeeze every last bit of performance and sort of memory optimization out of your program. Then you're going to start reaching for these kind of tools. Okay. So there were some other additions to the runtime package. So runtime package got some new stuff.
There's runtime ad cleanup. This fits in with the weak package. So there's a concept in garbage collection called a finalizer. And the idea is when the garbage collector notices that a variable has no more references, you can set up a little bit of code, even in prior versions of Go, using runtime.setFinalizer that says, just call this callback right before the variable is deleted. Just right before the variable is deleted, call this callback and let me know about it, and then I'm going to do some work. So for an example, you might want to set a finalizer on a file handle and say, if there are no more references to this file handle, I'm just going to check that the file handle was closed with the operating system before it completely passes out of memory. You might do something like that. The problem with using finalizers, you might look at it and say, well, why are we calling, defer file.close? Because I could just set up a finalizer and it would close it for me. I could just let the machine do the work. But the problem with finalizers is because they're tapped into the garbage collection system, you don't actually know when they're going to run. And there's actually no guarantee that they're going to run. It could be the program just closes before it ever gets run. It could be that, there's so much garbage built up that the system crashes. There's not a lot of guarantees with finalizers. They're also really tricky. If you write it the wrong way, you might accidentally bring the variable back to life, which is a big problem that you didn't mean to, but because of whatever you were doing in your finalizer, now the variable, which used to have 0 references, has 1, and so it has been resurrected, and you get these zombie variables out of that. So there's a new function called runtime.addCleanup. And the way that it's set up is supposed to prevent these sort of problems. And so instead of taking a callback where the callback gets the thing that's passing out of memory management, instead of getting that when the variable goes away, what it does is it's supposed to get some other variable, which seems a little bit weird. Like, why would you just pass some other unrelated variable? But going back to the file example, one thing you might do is you could say, look, if this file descriptor passes out of references, there's nobody else holding on to it. What I'm going to do is to use the file ID, the int or uint or whatever it is that describes the file, and I'm going to use that to close it instead of a full file object. And by using the file descriptor instead of a full file object, I know for sure I won't accidentally resurrect the file object, and I can check that it's closed that way. So it's another one of those things where it's like, if you're messing around with set finalizer, you should probably know what you're doing. And hopefully runtime.addCleanup is going to be one where it's easier to do it correctly, to not accidentally create these resurrection cycles, these zombie cycles, armies of undead coming back from the earth. So that was a problem before. Go 124, fewer zombies, much weaker. So they've nerfed this release.
Nice. There were some other behind the scenes. I was reading the release notes and I saw that there were some incremental like CPU performance improvements in the runtime, like basically 2 to 3%, right? Like depending on the application in your use case, right? Like things like that. And I think that's kind of been in a lot of releases, releases that I read, I always see like a little, a drop of those little nuggets, right? So it's like there's a thing about sort of the Go sort of ecosystem where the Go team is always sort of doing improvement work behind the scenes, even if you don't necessarily notice them, that over time add up to significant, performance boosts for your applications. And all you have to do is simply, recompile your program in the latest version of Go, right? So I thought that was pretty cool. Along those lines, it seems like that particular sort of improvement seems to be around the use of a new kind of mapping structure, like a Swiss table. How much do you know about that? It sounded like very new to me. I wasn't familiar with that concept. Swiss tables seems like they optimize storage and lookup.
Yeah, this is something I don't know the details very well. I think it was something where it was. I had seen the issue for it. I forget what company it was. I want to say it was like ByteDance, TikTok. But there was a company that was looking at the performance of maps in Go, and they said, in our application, we can make it a little bit faster if we use this other algorithm for the maps. And so then there was like a years-long issue to get this merged into the actual Go project, to go from being, one particular company has an internal fork of Go where they do the maps slightly differently and they find different performance characteristics, to something where it's like, okay, we know we can roll this out without crashing all of the existing code. And that's something that's really nice about Go, is just because of the commitment to backwards compatibility, because of the commitment to keeping APIs the same and making sure there's no breaking changes. It can be something like this where you're making a change that adds, multiple percentage points of improvement to the runtime without breaking existing code. And so people are able to upgrade to it without worrying that, like, oh no, all of my existing map code is now broken, or I was relying on different things. In a very early version of Go, one of the things they did is they made it so that the order that you go through maps is randomized, because they were worried that people would get too committed to, if we have this particular implementation of how maps go through the keys, and then later we want to change it from being one algorithm to another, people might expect that, no, the order is it goes Z, Q, R, M, J. Everybody knows that. And my tests are going to break when it goes, B, R, L, J, So whatever it is, whatever the order is, even if it's like an arbitrary order, people might get used to it. And so they deliberately made it that, like, on startup, Go picks a random order for the maps. And then, if you write a test where you're expecting a particular order from the map, you will be disappointed.
Right. Pick a different data structure if you're looking for, ordered keys or something. Yeah, that's the maps is not for you, right? So, okay. Yeah, definitely appreciate that. And I don't know whether my applications are going to benefit from that, but if they ever do behind the scenes, I'm pretty psyched about that. Let's talk about testing. It's not very often you get an update to the testing package. It's been pretty stable for a long time. What is this new testing related package?
There's a new, it's experimental. So this is one where, again, it's really tying in pretty deep to the runtime and how things work in Go. It's a new sub-package called testing/sync test. I think in order to use it, you have to, I'm looking at the notes here. It says you have to set Go experiment equals sync test. Otherwise, when you try to import it, the code will just say package sync test not found. But once you do set that variable, you're able to use two different functions. One is called sync_test.run, and that just takes a callback, and whatever is inside of that callback is in the sync test bubble, and then sync_test.wait. And so what sync test does is it basically starts and stops the system clock for you. So if you've written anything that interacts with time, you've tried to write tests for it, you've probably gotten a little bit annoyed, or maybe you've written your own package that can mock out time. Because the issue that you run into pretty quickly is, like, I need to reproduce this test, but when I do it on Monday, it says the day is Monday, and when I do it on Tuesday, it says the day is Tuesday. This test is not repeatable. So anytime you're using time.now, you have that problem. And you also have a problem with waiting. You're writing something about timeouts, and you say, okay, I want this timeout to happen in, 100 milliseconds the first time and 300 milliseconds the second time. And if it doesn't get it then just go ahead and wait a full 10 seconds before you retry. Well, if that's your test, you're pretty quickly going to be very bored during test runs. Those sort of waits during testing really quickly add up to a bad time. There's a blogger, I don't know how to pronounce their name, but Xeazo, but they wrote a blog post called Time is Not a Sync Primitive. But yeah, if you just search for XE and then time is not a sync primitive, I think it'll come up. But that was a really fun one about how a lot of times when we're writing these sync code things and we're trying to test them, we end up saying like, okay, just wait 50 milliseconds and see if this thing is done yet. Wait 2 seconds, see if it's done yet. It's a strategy that is usually the easiest way to test something, but then the downside of it is that at the end of the day, you're really just like hoping that things get done in time, and it ends up with the test being very flaky. So the way that the new sync test package works is that when you call something within synctest.run, it changes out how time.now works. It changes out how time.sleep works. And inside of this callback, all of those calls to time now and time sleep are now just simulated calls. They're just mock calls. And then when you call time.wait, it waits for all of the Go routines that we're using now and sleep to advance. So with this, if you're testing how long it takes to have your code sleep for 1 minute. In the old world, it would take a whole minute. But now if you do it inside of, synctest.run, it can take, only microseconds.
Whatever, however long you need. Yeah, now you can control time within
you can
your
control
own bubble.
time. Yeah, so Go 1.24, control time, master the flow of time.
Nice. All right. So speaking of the testing package, they added a new function to the benchmarking. It's the b.loop. So typically when you're doing benchmarking and you're doing sort of a loop iterations, we typically reach for the b.n, right? So you're kind of ranging, basically, until the b.n, and n is determined by the runtime for however many iterations it wants to, and until it can establish a baseline for your benchmark. But there's this new b.loop that supposedly gives a couple of new benefits. Like, why should I care about this b.loop?
Yeah, this is I'm a little bit not disappointed, but I think it's a little bit unfortunate the way the timing worked out for this. That I have just rewritten a lot of code to go from saying for I : = 0, I less than b.n, I ++ to saying for I. Well, a lot of times you can just say for range b.n using the new thing in Go where you can do range and then an integer, and it will just range an integer number of times. So I've replaced a lot of code to do for range b.n, but now I get to replace it with instead for b.loop parenthesis. But it has some advantages. It's not just like a rewrite for no reason. So with the old system, when you wrote a benchmark, one of the things you might have to do is you might have some setup code first, and then you might have some teardown code afterwards. But with the new system, if you use b.loop, the compiler can plug into it and make sure that it knows where the setup code is and where the afterwards code is, and just automatically subtract those from the benchmark timing. Another thing that's a big problem with benchmarks is you'll sometimes see this online. Somebody will post like on Reddit or something. They'll say, look at how fast this is and look at how fast this is. And you notice that both of the benchmarks are coming in nanoseconds. And you're like, oh, you're just measuring how fast it takes to do a loop, and you're getting noise and you're thinking that you're measuring something. Because in those cases, what happens is the compiler will notice that nobody is using a certain variable and just go ahead and optimize it out. So in normal code, you do want the compiler to optimize as much as it can and to take out any dead code and to make sure any code paths that are not actually being used are eliminated. But when you're doing a benchmark, you want to leave that in at the top level because you do want to measure how long the top level takes. But on the other hand, you still want to optimize the lower level because you want to get a realistic idea of how long it takes in production. It's a little bit tricky. So by tying the b.loop into the compiler, what they can do is they can make sure that there's no optimizations performed on the text between for b.loop curly bracket to the other curly bracket. Anything that's inside those two curly brackets, it can make sure is not optimized. But then the code that's inside of there that calls other code, the other code that is called will be optimized. So it's a little bit tricky, making sure the optimization level is just right so that you don't have any problems with that. I know in benchmarking code that I've done in the past, usually what I would do is to just set up a global variable, and I would call it like sync or something like that. And just like at the end of the testing loop, dump whatever the variable result is into the sync. And if you do that, that's like a kind of hacky way of making sure it doesn't get optimized away. But with new b.loop, you don't have to worry about it. It'll just automatically apply the right level of optimization, not too much, not too little.
Right. That makes sense. So
there are two. Before we move from testing, there are two more minor changes to testing. There's testing.context and testing.changedir. So testing.context, sometimes when you're writing a test, you need just a random context. You're testing something that takes a context, and so you have to pass a context in. As for those, I usually just end up doing like context.background because it's like, I don't care, whatever. But the new testing.context is useful not just as a replacement for context.background, but also because it sets a timeout. And the timeout that it sets is when the test is over, it cancels the context. So before all the cleanup code runs, but after the test is over, it will close the context. So that way, if you have anything that's waiting on the context to be canceled, it will notice it, close itself, and then the test cleanup will run. So it's a little bit more convenient that way. It serves multiple purposes. It's like, this way I don't have to just reach for context.background, and also I get something that makes sure that anything that's relying on my test is closed in time. And then testing.changedir, this is something you could just write yourself, but what you might not realize when you do os.changedir is it's something that affects the whole process, because the directory that a program is running in is something that's set process-wide. So if you're running two different tests in parallel and then you call changedir, you could screw things up. You might have one thing changing it and another thing changing it at the same time, and those could conflict, and then you would have some sort of error, or just, again, another way for your test to be flaky. So by adding the new testing.changedir, it makes it so that it knows not to run in parallel. It knows that if somebody else is changing the directory, not to clobber it. It knows how to restore the directory at the end of the test. So it just handles all of that stuff for you. It's another one where it's like, if I just use the testing version of this, I don't have to think about whether anybody else could be changing the directory. I just change the directory and it works.
That's pretty cool. The context one I find interesting. Normally, if I wanted to sort of have multiple pieces of my code within a context of testing, rely on a context, I'd create some sort of global context and then make sure everything uses that. But this sort of it feels like this testing.context sort of formalizes that just put some semantics around that everybody can sort of agree on. This is like the way to do it now. It's just been formalized in some ways, which I think is pretty nice. So moving off of this was a lot of testing related stuff. When I think about it, there was a lot of changes in related changes in this release. Now that we've talked about it, another update, this time to the OS package, adds what I think is definitely an improvement, but kind of something I wasn't thinking about in terms of when I have a program that is doing sort of I/O, like disk I/O. Like I didn't think of basically that a program, right? You basically, once it has access to your disk, it can kind of go anywhere. But this new introduction of this root, this os.root, kind of forces, basically kind of sandboxes where your program can kind of go, right? Am I thinking about this right?
It's not sandboxing your whole program, but yeah, it is providing a little bit more security and protection. So there's a new os.root. Let me see. Is it a type? I think it's a type.
It's a type, yeah.
Yeah. And And what it basically does is anything that is in an os.root it can only access things that are within it. So it's protecting against a very specific kind of security problem. os.root, it's a type, and what it does basically is it protects against a very specific kind of security problem that you might have. So let's say you have a server that you're trying to protect, and an attacker has gotten partial access to it. And what they can do is they can write to a certain file, but they can't necessarily do operations as other users. Well, one thing that they might try to do is they might try to change the name of a directory that you expect to be in, and then see if by changing it, they can trick you into doing something that you shouldn't be able to do. If you are trying to write to the user / downloads directory, if they can change it so that downloads is now a symlink to the passwords directory, and then they write a download file called, new password file or whatever, then they could use that to chain an attack. Another kind of attack an attacker might do is to just see if you're not properly sanitizing your file names. And instead of writing out a new file that's called, myfile.txt, you write out a new file that's called .. /myfile.txt. And so suddenly you've put a myfile somewhere you shouldn't be allowed to put it.
Right.
So what the roots do is most modern OSs now have a way of saying that, look, whenever you open a file or you write something or read something, make sure that you're doing it relative to this other file. And if this other file gets renamed or moved or does something else, whatever, who cares? You're still supposed to do it relative to this other file. And so that's in Go is now called root. So there's a new function called openRoot, and what openRoot does is it takes a path, it opens that particular path as a root, and then all commands after that are going to be relative to the root. So this might be useful again, like if you have a server and you want to serve a particular directory. So let's say I'm going to let my users upload files into this directory, and I'm going to serve files out of the directory, but I don't want users to be able to just read and write arbitrary files on my server. Well, what you could do in that case is to make sure that the directory that you're reading and writing from is a root. And so then you know that all reads and writes are only going to be within that subdirectory. There's no way for them to break out of that jail. Now, again, it doesn't apply process-wide. So if you have control of the Go code, you could just write another function that says, open evil.txt. But this is assuming that they're only going through the root in the Go code. But it makes it easier to write code that's correct, and it makes it easier to make sure that all of the commands you're doing are within a root. So one way that this is useful is if you need to make an fs.fs. So there's the io/fs package, which has the sort of virtual file system type in it, the virtual file interface. So if you're using an fs.fs, up to this point, you might want to make sure that everything that's happening in your fs is contained within a certain bubble. And this is going to be a little way to make it easier to make sure that everything that you're doing is within that bubble.
It's definitely worth noting that there, depending on the operating system you're using, there might be some like a variance in how the root is treated. So if that is something that you need, it's definitely gonna check out the documentation. It's gonna the root is gonna behave differently whether you're on Windows or Plain 9 or some other OS. So definitely check out the documentation if that is something you need.
Yeah, so on most systems, the root should just go without you having to think about it. Like if you're using a modern OS, the main problems you're going to run into is if you're using something like Plan 9, where it's sort of user supported at this point, or I think WebAssembly doesn't have a way of doing it. But for most of the modern kind of things, your Linux, your Mac, it should be fine.
Yeah, before touching on some of the minor stuff, we have had a lot of tool sort of changes. So when we're talking about sort of the Go tool chain, right? So whenever you type, the command, Go on your command line, right? You're using the Go tool chain. So we've had some additions and some changes to the tool chain. Anything worth sort of calling out here?
So there's a new, I guess there's a new way of interacting with the Go tool. So a thing that you might have seen if you're using JavaScript is there's the idea of these subcommands. So one of the things you can do with npm or yarn is if you publish a package and you manage to get a certain name for it, you can make it so that if you do npx run blah, 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 it will look for a package that's named whatever dash blah, blah, blah. Or if you do yarn create whatever, it will look for a package that's called yarn dash whatever. And so those are sort of like handy ways of like making it so that you can just do one command and run this other package through it. So in Go, we have ways of doing that similar things. So you could do, even in Go 1.23, go run github.com/user/foo at latest, and it will download that, it will run it, it will do exactly what you want. So that's something you can do, but it's a little bit janky in the sense that you do have to like get it set up and make sure it's working, paste out the whole command. But with the Go tool thing, what you can do is you can actually, in your Go module, declare what tools you're using and make it so instead people can do Go tool whatever, and it will find the right package and run it for you. So an example of this that they include is there's been included in Go for a while something called stringer. And what stringer does is if you point it at a Go enum, or enum, however you pronounce it, it will look at that and make string methods for all of the different values in the stringer or in the enum. And so, that's something where today how you might have it set up is you might say, okay, I'm using the version of stringer that was released whenever it was. I happened to run the program, didn't write it down, didn't really care. It doesn't change very often, so it's probably fine. And if you do go generate, there's a comment in my code that says go generate : stringer whatever. And so the go generate command will cause the stringer package to run, and then that will output a Go file, and then you check the Go file into your code. This just makes it a little bit easier that you can record exactly what version of stringer are you doing, and if you want to run it, instead of having to like pull out the full command for it, you can just do go tool stringer, and it will run exactly what it's supposed to run.
Right. Okay. Yeah, it's I have a sort of a standing bookmark in my browser to sort of go through all the different tools available in the tool chain to know like what like I'm so like every day like I'm using a typical set of things, right? I'll do the Go run and the Go build, the Go test and the Go mod, right? Like all these sort of the day-to-day sort of tools that I use with the Go tool chain, but rarely do I have to sort of go outside of that, and perhaps that's sort of by design, right? So if you know you need these kinds of extra sets of tools, if you're doing sort of a compiler flags or some sort of optimization work, then these things are going to exist and they're going to be there for you. But I'm curious now because I keep seeing some additional tools being added to the tool chain, and I don't know a lot about what a lot of them do. So I need to go back and sort of see what's been added since I've been using Go for a few years now.
Yeah, what's nice about this is that you can write your own tools and you can share them with your team, or you can have an internal tool that's just for your team, or you can see what other tools other people are writing. And it gives, just a handy way of making sure everything has the version correctly synchronized, and it's easy to run, and you don't have to remember like a 500-line command.
Yeah, it's kind of like kind of like I like to have a make file in my projects. I know some people are going, make files, that's like old as Unix. Well, yes, it's still useful. so I'll have targets in there. It's sort of a go tools, sound analogous to something like that, where you don't have to. It could be a simple command, but with all the different flags and the wizardry that can happen in the command line, it's useful to have sort of one way of doing things that the whole team can share.
Yeah. I personally, I don't love make files just because it's like the syntax is so ugly and everything has to be .phony. And usually for Go, your make file is just like go install, go build. It's not very interesting. But it is something that, most people have it. It's pretty easy to do. A lot of people know how to write it. So it makes sense that it's pretty widely used. Especially as you have like more complicated commands, you want to make sure they're written down somewhere. And so the make file is the somewhere. But hopefully this will mean more people can live that make file free lifestyle where you're just remembering what the commands are or just having a handful of simple commands.
You just gave me an idea for my unpopular opinion. So, we'll talk about this again in a minute. All right. So, generic type aliases. What is that about?
So this was just sort of, it's part of the slow rollout of generics. This has sort of been a limitation that they've been aware of from the beginning, is that there's a concept in Go of a type alias. So if you have a certain type, let's call it just foo, and later you decide, well, actually I need to move foo to a different package, or I need it to be switched around so that this package has foo and this other package is importing it. What you can do is you can have a type alias where you say, you know what, these two types are equal. And when they created the concept of type aliases, one of the things is they went back in time and they changed how the byte type works. So byte is now an alias for uint8. And so in your code, some places you'll use the word byte because you want to be clear that you're just talking about like bytes on a wire. And other places in your code, you might write uint8 because you're just talking about, well, that's how big it is. And this is really just like a mathematical thing. But under the hood, those are aliases. And so that's been around since the original version of Go. But in a later version of Go, they were like, oh, let's have a concept of alias, and let's make it so anybody can make an alias to anything, or at least anything that's importable. So when generics rolled out, you might say, well, how do I do an alias of a generic? And at first they were like, there's not a great way to do it. And now they've just finally filled that hole so that if you have a generic type that's defined in one package and you want to use it in another one, and not just use it, but like replace the type itself or completely redo it, now you can use a generic type alias.
Okay, that sounds relatively useful. Yeah.
Yeah, I think where this is most useful is when, with a type alias, you can make it so that you're aliasing an unnamed type. So this is sort of like a pretty fine distinction in the language. But if you have, like, say, function that takes T and returns O or something like that, the type that's the function by itself is one thing. But then if you have, like, type doer, and you define that as a function that takes T and returns O, the doer type and the raw function type are technically two different kind of types. And so there can be places where it will only take a doer and it won't take a raw function, or it will only... I don't think there are places where it will only take the raw function, but it won't take the doer. But don't quote me on that. But with the generic type aliases now, even for generics, this isn't going to be a problem. You can always just substitute one for the other. And I know that one place they were thinking about doing this, although I don't believe it's in this release, is for the iter package. The yield functions inside of an iterator. Before, they were thinking it would be nice to have those as an alias. But it wasn't possible because generic aliases weren't possible. But now the yield function itself, you can write an alias. So just in terms of making how many physical times you have to hit the keyboard for typing faster, you can create an alias to those inner yield functions, to the type of them, and that just means that there's less to write out.
Right. Yeah, and probably another common type alias that folks might be using and not realize it's even an alias is the empty interface alias is
Oh yeah,
it's
that's
any.
another
You
one.
can use right, yeah. Any is the same thing as the empty interface, which I think is a good sort of semantic way of sort of relaying meaning, right? Like like it's more clear what the intent is, and a lot of times, as we write code, when humans are writing codes for each other, intent, communicating intent is often very necessary. So let's talk about some of the minor stuff. I know there's a couple here that are pretty exciting to me. What are some of the minor standard library updates that were made?
So the rollout of iterators continues. There are some new iterator functions in strings and bytes. So the one that's probably the most useful is strings.lines. So you've always been able to split something into a slice of lines with Go, but now you can get just an iterator that will go through all the lines in a string or in a slice of bytes. And so this is handy if you're just going to go through the individual things. You don't need the whole slice all at once. You're probably just going to use them to process each line individually or to send the lines to somewhere else. Now you can just very easily do that. And it also works for split and split func and that sort of thing. So that's one where it's just sort of the slow march of iterators throughout the standard library.
Right.
So another thing that's been added is the crypto/rand.text function. This one is one that you run into every once in a while where you just need some random text. Let's say you're making up a key or something like that. And so then you're like, okay, I know I need some random text here. How big does it have to be? And so then you search for it, you ask your AI companion, you look on Stack Overflow, you're like, how many bytes do I need for this? And you're like, is 2 to the 64 bytes, is that enough entropy? How many, you have to get different people's opinions and stuff. And then you have to write the algorithm, and it's not a hard algorithm. You should be able to do it, but you do have to worry oh, I made a mistake in how I was picking out the letters for my random string, and I accidentally am oversampling from lowercase letters because I didn't realize that there's an off by 1 here, and so the last thing in my alphabet gets 1 extra pull versus everything else. And so it's very slightly more likely that I'm going to use the letter lowercase z than anything else. Anyway, there's just little bugs and stuff that can creep in. And so what crypto/rand.text does is it's here, it's a string. It's random. We promise that it has enough entropy for practical purposes. Don't worry about it. So it's really simple. It's really easy. The string, you're not allowed to pick the alphabet. There was a lot of discussion back and forth in the issues about, should we let people pick the alphabet? Because isn't that part of the fun? And it's no, we're just going to give you something that's base 64 and you're going to like it.
All right.
And it's fine. It's useful though.
All right. The encoding JSON one is new. When I read that in the release notes, I was actually quite excited about that because I've run into the situation where I wanted basically where the 0 value, right, for maybe an integer type, right? I wanted to literally not relay, right, that JSON, not relay that in the payload that I was sending out. Basically I wanted to treat the actual value 0 as sort of an empty field and sort of, we have omit empty. So now we have a new tag. Tell us about that.
So let me make sure I get the name straight. So the new one is
omit 0,
right? And the old one is omit empty. And so basically the problem was a lot of people would look at the old tag, the omit empty tag, and they would think that it did one thing and it didn't do it. And so what they've done is they've added a new tag that does the thing that you thought the old thing did. So with JSON, right, the way that you usually will be handling JSON in Go is to you define a struct, and then you add these little comments after the fields of the struct that are called the struct tags. They're just little strings that go after the type. And those define where and how the thing is unmarshaled. And so you can do a few little comments with the JSON unmarshalling. You can tell it, for example, that I want this number to always just be sent over the wire as a string and pulled out of the wire as a string, just to make sure we're not losing any precision on floats or something like that. There's a few other little things like that you can do. And one of the things that you could do was omit empty. And so before when you would do it, you would think that, okay, I'm going to put omit empty on my time.time. And so that way, if there's no deleted at, if deleted at is 0, then it will just omit the deleted at time, right?
Right.
But it wouldn't it wouldn't actually omit that, because it's like, well, it's 0, but it's not quite the right kind of 0 that you think it should be. So this is something where people have like filed bugs repeatedly of like, I put omit 0 or omit empty on this and it didn't omit it even though it's empty. And it's like, well, it was technically not quite empty in the right way. And so people were, repeatedly filing bugs. So a project that's sort of flying under the radar and hopefully will be ready for prime time pretty soon is that they're working on an encoding JSON /v2. And if it comes out, it'll be really cool because it'll be, faster, it'll have more options, it'll, be able to do things in different ways. But as part of this V2 work, one of the things that they were saying is like, well, it needs to be backwards compatible with V1, but we also really want to fix this weirdness where everybody thinks omit empty works this way, but it works a different way. And so they've come up with this new idea of omit 0, and it's like, okay, omit 0. It works the way you think it does. We can even put it into V1 of the encoding JSON package and, just ship it. So I think this is something that'll make people happy because it's another example of like, you were thinking about this thing and now you don't have to think about it.
Right. And I definitely appreciate the fact that the standard library also gives you control to determine what 0 means to you, right? So all you have to do is add an is0, right, a method on the type, and then you can then basically add during on marshalling time or during marshalling time, basically that method can be called, and then you decide what 0 is, right? You just return a Boolean, right? If you say, hey, this thing can a real value, but if I think that value is 0 and the field as a result should be omitted from the payload, you control that. So I think it's a very good compromise, at least for the V1 encoding JSON package until we get a V2.
Yeah. And time.time is something that already has an is0 method, so you don't have to define it yourself. Exactly.
So the last bit we'll cover here is something that you yourself added, right? And that's actually pretty exciting to me. Tell us about that.
So this is something where, a lot of times when I see that the Go release cycle is wrapping up, we're moving towards the freeze time, I want to go onto the issue tracker and see what's a proposal that's been accepted, but and it's simple. It's something that's like a 3-line function, but nobody has done it yet. And can I go in there and can I volunteer to be the person who does it? And so in this particular cycle, I was looking through the list of accepted but not accepted proposals that were not yet merged into the Go standard library. And I saw that slog discard handler had been accepted but not yet actually implemented. So if you were listening to the old Go Time show, you might remember when Johnny was super excited about the release of log/slog. The SLOG, the slog package, is for structured logging. And what it lets you do is you can log values in such a way that you're not just like omitting a bunch of strings, but you're omitting either JSON or a binary format or something where you can say like, how long did this RPC call take? Well, it took 13 milliseconds, and you can omit the 13 milliseconds in a way where you're logging whatever your log analyzer is, your metric system can analyze that and can see the 13 milliseconds and understand what it is. So structured logging is really cool. It's really useful. But again, going back to testing, when you're testing, a lot of times you're like, well, what am I supposed to do with all these log messages? I don't want them like just clogging up how this thing works. It's just noise. I need to pass in a logger. What logger should I pass in? Or even if you're running, let's say, you want to have a silent mode and you're like, okay, I want to run this in silent mode. How do I run it in silent mode? And so one thing you could do before is to just make a JSON logger or a text logger and then set the verbosity so high that like nothing is at that level. So just, because, you have log levels and you could say this is an error or a warning or info or debug, and just go ahead and set it up to the maximum level and say like, okay, only show me a level 1 bazillion error message, and it's like nothing's a level 1 bazillion error message, so nothing will come through. So that was one way of doing it. But with the new slog.discard handler, it's very simple. It does what it says. It just throws it all away. So Carlana has now thrown all of your precious data away, and I will do it again if you don't listen to me and donate to Spotlight PA. That's something that, it's one of these ones where it's like, it's not a very big function. The actual testing, I'm sure, was like longer than the function itself. But it was a way that I could contribute to the Go project. And I'm happy when I can find things like that I can push through.
Yeah, when I saw that, I was like, yes, I can go back into a lot of my code bases where I'm creating, I would create like a no-op sort of handler, right? That basically, with the handle method, I'll just basically just return nothing, right? Just basically just completely swallow up whatever log that would have otherwise be emitted to standard out of standard error or something like that, right? So now I can actually remove that and actually use a discard handler proper and just, reduce the noise from my code. So definitely appreciate that. Thank you.
Yeah, one of the nice things with this is that we have like a test on it which tests that it doesn't allocate any memory if you pass something to it. And so since this is in, the Go standard libraries testing system, if something changes and somehow or another it ends up accidentally allocating, there'll be a regression, somebody will get a flag, they'll be like, oh, that's weird, we changed how this thingy works in Go 1.50, and now the discard handler is allocating memory, but it shouldn't be. Well, that's not going to happen because they're going to see the regression and they'll know that something went wrong. You don't have to worry about it.
Wrong. Right. Awesome. Definitely like the standardization. All right. It is that time, folks. Unpopular opinions. Carryover from Go time. Definitely love it. So Carlana, what did you bring for us today?
So this is one, I wish that Kris was on the show because I know that this will make him very upset.
He'll hear it in post.
Yeah, he's going to hear it in post, and he's going to write me a 5,000 word essay, just beautifully written, the most writerly thing you've ever read. But it's about REST interfaces, and specifically about in HTTP, your HTTP verbs and your HTTP status codes are for clients you don't control. So a lot of times when you're making a REST service, you end up spending a lot of time debating. Should it be like a 403? Should it be a 401? Should it be this? Should it be that? Should we return a status created for this? Should we just return a regular 200? Should we take a post method here, or a put, or a patch? There's lots and lots of details that you can work out about how exactly you want your REST API to be. But I would say that when you're thinking about these details, you shouldn't be thinking about it in terms of the clients you control. The clients you control will do whatever you tell them, right? So let's say I'm making a service and I control, let's say I control the client and I control the server, and I need to transmit some information. I can make it so that what the client expects to see is a 500, and what the client sends is not even a real verb. I can just make up a verb called a Baz verb or something. So when you control the client and the server, you can have them talk however they want. And that's the principle behind SOAP and GraphQL, where they're not using the quote unquote right verbs, and they're not using the right status codes. But that's because they control both ends of it, so they don't care. On the other hand, though, those verbs and those status codes are important for clients you don't control. And so what are the clients you don't control? You don't control people's web browsers. So a web browser, when it sees a 404, knows that this web page didn't correctly load. It's going to be weird about it in the history. It's maybe won't autocomplete it in the history. When you send a post in a web browser, it knows that when you press back, it should warn you that you're going to resubmit the form. Web browsers know that 500s are a problem. who other clients that you don't control, like Googlebot. Googlebot knows that a 500 means that there's something wrong with the web page, and it's not going to surface that in search results. Googlebot knows that a 400 or a 404 is not found, and that this web page doesn't exist, and it's going to stop trying to spider off of that page. So there are lots of clients you don't control. You don't control like CDNs. I mean, maybe you have like a loose control of your CDN, but you don't have control of exactly some of the finer details. And so your CDN, if it sees a GET, might assume that this is idempotent and it can replay the message that it gets to multiple clients. But if it sees a post, it knows that like, look, this is not going to be replayable. It has to be just like one and done. So when you're thinking about what verbs to use, what status codes to return, think about it in terms of not what does my system do, what does my client do, or what does my server do. Think about it in terms of what do the clients I don't control do. So the time that you're spending figuring out what your clients do, it's like it doesn't really matter. You can just like stuff it into the JSON body, or there's like a million ways you can pass things from one system to the other. But for the clients you don't control, those are the ones where you need to think about what are the verbs, what are the status codes.
Okay. I mean, that's a fair. Well, I don't want to poison the well. So we'll let people tell you how they feel about it.
I'm very excited to read Kris's rebuttal.
It sounds like a sensible approach to me, but we'll let others chime in. My unpopular opinion, and I told you we'd come back to this, is that I think you should use make files wherever you can, for very sensible reasons. Like, for example, all right, once upon a time, when back in the day, many moons ago, when I first started using sort of CI/CD pipelines, across various SaaS solutions, I went through this painful process of converting from one product to another. I think we were using. I think it's no longer around. There was once upon a time, a very popular CI/CD tool continuous integration platform that was sort of popular. I can't remember the name, but it doesn't really matter for the example. But basically, it had its own sort of a language, right? It had its own sort of a set of things you could sort of call and rely on. So you could describe in a sort of an imperative way, like, okay, I want this thing to happen, move this artifact to this location afterwards. But it was very specific to that particular sort of platform. And when someone higher up decided, hey, we don't want to use this product anymore, we need to move from product X to product Y. Now I had a bunch of sort of a YAML-like syntax that was only sort of recognizable within one platform, and that I had to completely rewrite, for a different platform. So after that experience, I was like, you know what? I want to use make targets, and I want to make my project, right, have all the things, that bits and pieces that it needs through make targets. So the testing, that's called make test. Building, that's called make build, right? Deploying to prod, that's called make deploy, right? So I could encode all these commands, right, into a make target, and then have that make file go along with the project, and whatever CI and CD platform I was using, right? Whether it's one thing today, something else tomorrow, I make all of them call these make targets, right? So for testing, if I have multiple parts of the test, maybe I'm doing integration testing in some cases and only unit testing in other cases, whatever control flags and whatever needed to happen, whatever commands need to be issued, those platforms would only have access to or should only ever call my make targets, because I wanted to control what they were doing. So for that reason, I never sort of, no matter how well featured or how good those sort of CI/CD platforms are, ultimately I don't want to bake a lot of assumptions on which CI and CD platform we're going to be using 2, 3, 5 years into the future. Like, I'd rather have everything be sort of make file invocations to sort of have more control over that. So that's my reasoning for encouraging the use of make files, and I think just make files have stood the test of time, right? It's an incredible tool. Yes, the syntax is not beautiful by any modern standard, but it does the job, and it works good enough, right? It's good enough for most sort of orchestration of commands and things of that nature.
Yeah. I mean, I'll definitely agree with the principles behind it. I just don't like the make syntax. So I agree with you that it's important, like, not to get locked into your CI/CD pipeline. I really do prefer having it that, like, I usually just write a bash script, and it's like I have functions in the bash script. And so it's like, there's the test colon back end, test colon front end. And those are the things that, like, do the deal. Now, bash is actually, like, I can be argued either way, which is worse, bash or make. But I argue that make is worse because make is like bash plus more, and more is worse. But they're both pretty bad. And then I do like, that make is everywhere. And a lot of times, if you're using something that's unusual, you have the problem of, like, how do I install this thing in order to, like, do the rest of the installation? So, like, in the Python world, I've definitely run into problems where it's like I'm using this tool to do Python installation because, the default pip is weird or whatever. But then I run into the problem where the tool itself is, like, upgrading, and now the tool is out of sync. So I need a tool that syncs the tool before I can sync the rest of the packages. And so with make, you're like, okay, make is everywhere. Probably whatever the difference is between make on, platform A and platform B is not relevant, or, like, I shouldn't be using make to the detail level where that should matter. And so I think that's good as well, is to, like, try to, like, stick to a universal generic tool. I will say that that's something that's interesting thinking about, like, the go tool command we were talking about is with that. I know there's systems that are written to be basically make replacements in Go. And one of the problems with those is, like, well, I've got to install it first before I can use it. And so how am I going to install it? So if you have it as a Go tool, you might be able to just do Go tool, and what is it, Mage, M-A-G-E? Go tool Mage, and then have it come up. And it's like, okay, now Mage is working, and I can tell Mage to do the whole rest of the build for me. So that's one way to work around that problem you have with Mage not being installed everywhere, but make is installed everywhere.
Right.
But yeah, I just hate the make syntax. I just find it so gross.
Yes, it's not great, but speaking for somebody who's been using it for many years, I've gotten used to it. Again, it's not the best thing, it's not the most beautiful thing to look at, and it has some quirks for sure. But it's one of those things that's good enough. And over the years, although I've seen a lot of DSLs, emerge, a lot of these kind of tools emerge, and especially having been in other sort of programming communities and environments where they have their own tool chains, from the grunts of the world to the what is it, the groovies and all these other things. Like I've seen so many
I've
of these.
had to use Groovy. I understand your pain.
So I've been around the block a few times to be like, you know what, let me just stick with Makefile, and that's consistent enough. And I think it's one of those things where even if I told a junior developer, hey, here, learn Make, right? And
you're
go
teaching
find
them
some
something that's going to be useful, even if they change
Exactly.
jobs, or if they go somewhere else, or, they move up, or the system changes, they're still going to be able to use make files. And so that is an advantage. I know for regular expressions, when I was like a junior developer, I would look at them and I would just be like, I don't want to learn regular expressions. This is so ugly. This is so dumb. It always has these problems where it's over capturing or under capturing. I just don't want to use them ever. And at this point, I've sort of grown like a grudging respect for, like, they get the job done. They're pretty similar everywhere. You can write one that will work on most things. Like, if you're writing something that only works in a particular regular expression engine, then probably what you're doing is too specialized, and you should, like, build a real parser. But if you write something that's, like, generic enough, it'll work in Go, it'll work in PHP, it'll work in Rust, and it'll match whatever you get. And I think it's a little bit ugly and whatever, but it's fine. And so make is probably in that same bucket of, like, it's ugly, and it's not what people would do if they could, like, have every developer in the world sit down and, like, build the perfect make system, but it's the one that's out there.
You're right. Yeah, it's one of those things. If you learn it, you're never gonna regret learning it, right? It's like SQL. No matter how many times we try to come up with a new SQL replacement, you go back to the to the original. It's one of those things you never regret. Learning, even if people tell you, hey, learn this new ORM or learn this new other syntax to extract data from things. A lot of systems rely on familiarity with SQL, right? And they'll even say, hey, this is like SQL, but blah blah blah, right? So it's one of those things where you learn it. Like make is one of those things. SQL is one of those things, right? Like those sort of foundational pieces of things that everybody should learn, I think.
Yeah, and I definitely agree with you on SQL. I love SQL C. SQLC.dev is this great Go project that's let you just embed your SQL right in your Go program. And so, like I learned how to use the Django ORM. I started to learn how to use the SQL Alchemy for Python. And it's like those I can't use anymore because I'm not on Python anymore. So that knowledge like didn't last from one language to the other. Whereas learning SQL now, even if I stop using Go and I switch to Rust or Zig or Zag, whatever comes after Zig, SQL will still be around, and I'll still be able to use the SQL that I've learned.
Right. Exactly. Timeless piece of knowledge. All right. Well, Carlana, always a pleasure having you.
Thank you for having me back. It's a pleasure to be on the new show. When I heard that Go Time was ending, I was like super bummed out, but it's back and it's better than ever because we've fallen through to the new code.
Nice. Well, with that, I say thank you, dear listener, and catch you on the next one.